everyone, my name is Vishwamohan and I'm here again to bring another interesting topic to master, which is the Node.js. So if you are someone who's trying to understand the full stack development, if you are someone who would like to understand the MERN stack, if you are someone who would like to understand that what typically the Node.js is, this lecture is going to be one single place where I'll make sure that anything and everything which is needed for you to get started with the Node.js is covered in this one short video. We'll try to understand the theory, we'll try to understand the concept. We also do the hands-on route where we write everything in the code in the live manner to understand how things are done. And if that was not enough, I'll also make sure that we take enough interview questions so that just after this video, if you're going to attempt an interview in the company, most of the questions from the Node.js, you should be able to answer that. So let's get started. So first of all, let's get started with the very first topic, which is JS and Node.js. First of all, let's try to understand that what is JavaScript and what is Node.js itself. My question to you people is that, those who are new or just starting, help me understand, is Node.js a programming language? Is a programming language. Is Node.js a programming language? Guys, you can just pause the video and put that into the comments. As per one of the surveys, if you try to participate, whether it's a live class or recorded, your focus increases by 30%. So pause the video and tell me if the Node.js is a programming language or not. Said that it is not a programming language, your answer is correct. So JavaScript is a programming language that we already know, right? JavaScript is a programming language. Now, if we look around the history of JavaScript, JavaScript was mostly used for the browsers. So whenever you make any website, say for example, Facebook, Google, Microsoft, so for making the websites, you go and render that on a browser, right? So JavaScript was a programming language which was mostly understood, only the browser can understand this. And for many initial years, JavaScript could only be used in a browser, unlike other programming languages like Java, C, C++. All these languages like C, Java, C++, you can write in your computer, in your operating system. There will be some kind of runtime environment where you will, let's say that you go and install a runtime environment for C++ or Java and you write a code there. We call that as a server level programming. But JavaScript, sir, for many years, it was only for the browsers. So now what was the problem? Let's say that, any application that I go and build, we know that any web application that you build will have the two parts, right? It will have a part called as a front end. Front end gets opened in browser. So since it is opened in the browser, at this place, the programming language that we were using is JavaScript. And then there's another part of the program which was called as a backend, right? The backend will be executed on some form of a computer. You go and call it as servers, right? Servers are nothing but the computers on which you go and run the code. Now, previously, since JavaScript could only be used for the browsers, for the server, a developer has to learn some other language. Say, for example, a developer might have to learn something called as Java, or they might have to learn something called as C++. Now, what it means, as a developer, I have to learn multiple stuffs. Right? If I have to make a complete application, I have to learn JavaScript also. I have to learn Java also. So it was very tough for a single person to know multiple tech stack, know multiple languages. Over a period of time, people realized that why not this JavaScript is used to build this backend also, and that's where the Node.js was born. The Node.js was born to support, this Node.js was born so that JavaScript can be executed inside computers also, right? So Node.js was developed to ensure that the same guy who knows JavaScript, he can write front end also and he can write back end also. He can write the code which could be executed, which could be run over the server. That's the beauty of Node.js. So what is a Node.js? Node.js is basically a runtime environment. It provides the runtime environment for the JavaScript. Now let's try to understand what this runtime environment itself is. Just like we as a human, right? For us to thrive, we need a favorable environment, right? For example, I'll need oxygen, I'll need water. These are the chemical formulas of water, oxygen. You need a right temperature. Only if all these criteria are satisfied, I can thrive, I can live. Same way when it comes about the programming, right? When it comes about the computer. For any programming language, for example, if I have to run Java in this computer, so for that I need the right environment. Just like human needs the oxygen and H2O, Java for to be executed in this computer needs a right runtime environment. So it will need something called as a JVM, Java Virtual Machine. Similarly, let's say that if I have to run Python, I need to have the Python runtime. If I have to write JavaScript also need to have some kind of runtime. If I am talking about the JavaScript, it also needs some kind of runtime. So Node.js is the runtime of the JavaScript. Node.js is the runtime of a JavaScript. So now if I go and relate Node.js and JavaScript, what does it mean? So if I go and talk about Node.js and JS, JavaScript is a programming language, right? And for this programming language, Node.js, what it does, it is the runtime. It provides the runtime. Node.js provides the runtime for it. And because of this possibility, now a single developer who knows JavaScript, right, they can work on the front end also and they can work on the back end also, right? The single developer who knows JavaScript can now work on the front end also, they can work on the back end also, and they typically are called as full stack developer. They are called as full stack developers. Now, as we have already aware, most of the companies in today's modern world, they're looking for someone who can do multiple things. They can do, the multiple roles. They can develop front end, they can develop back end. And that's why the people like you and me who are rock solid in Node.js have an immense demand in the industry. And that's why we are learning this. So with this, we have understood what and the why part. We have understood two parts, what and the why part. We are learning JavaScript and Node.js because that's what is the demand of the hour is. If you look around, most of the companies, every startup, in fact, if you look around the stack of theirs, they are making use of Node.js. So in this video, I'll make sure that everything which is needed to get started in this journey of full stack development, everything that you need to know about the Node.js, this one short video will ensure that you know everything around the Node.js to get started with. So if I go and talk about the Node.js, it is termed as asynchronous, event-driven runtime of JavaScript. If we talk about the official documentation of the Node.js, it is termed as asynchronous. This is one term. The another term that you need to talk about is event-driven. Event-driven is like reactive. Somebody scolded you, so you started crying. Somebody cracked a joke, so you started laughing, right? So based on certain event that you're doing. So it's called event-driven. And the runtime of JavaScript is more of like an environment that we already talked about. So we'll talk about what this asynchronous means, what are the synchronous means in detail. But as of now, you just think of what is Node.js. Node.js is asynchronous, event-driven runtime of JavaScript. We'll try to talk about each of them. But first of all, I believe you guys will be curious that what did the Node.js do that same JavaScript which was initially being understood only by the browsers now could be understood by the servers as well. So what did the Node.js did? What magic did Node.js did, or how Node.js was built? Let's try to understand how Node.js was developed. Because this played a great role in Node being available for everyone so that you can make use of JavaScript at the server-side programming as well. So for that, let's try to move on and understand a concept called as V8 engine. As we already know previously, in the beginning when I talked about that JavaScript was only understood by something called as a browsers. There are different kind of browsers. For example, one of the browser could be a very famous browser is say like for example Chrome. Now inside Chrome also, if the Chrome has to go and understand JavaScript, inside the Chrome browser also there has to be some kind of runtime environment. There has to be some kind of environment. The runtime environment which was used inside Chrome so that Chrome can understand how JavaScript will get executed and so that JS can run over the Chrome was called as V8 engine. So V8 engine was something which Chrome as a browser was using initially to render JavaScript in the browsers. And obviously it was done by the Google engineers. So the Google engineers, they thought that this V8 engine is already there in the browsers. Why not extend that? So this V8 engine was typically extended, this V8 engine was typically extended, right? This Google engineers extended the V8 engine, and it was extended to create Node.js. So Node.js was not built from scratch. Google engineers took help of V8 engine which was already running in the Chrome, extended it on the top of it and created Node.js. This whole V8 engine, if I go and talk about, this has been created in a programming language called as a C++. So C++ as a programming language, interesting fact, to make V8 engine we make use of C++, and which is a runtime for another programming language which is the JavaScript. So this is how guys Node.js was built. So I'm again repeating and iterating. What is JavaScript? It's a programming language. Initially JavaScript could only be executed on the browsers. Browser may, the runtime which was used was V8 engine. Later people realized that why cannot I make use of JavaScript on the server side also, on the computer also, and that's where the Google engineers extended the V8 engine, and that's what we call it today as Node.js, which is a runtime for JavaScript so that it could be executed on the server side. So now since we have understood what is Node.js, what is JavaScript, and what is the difference between them, let's try to first of all bring Node.js in our lab. I'm hoping most of you who's watching it already would have Node.js installed. If not, just try to follow the steps that I'm going to do. Right? So on the screen right now you see I've opened a browser, and if I have to install Node.js, I just have to go and type, let's say that, let me go and open the google.com. Okay. And here I go and type, let's say that I go and type Node.js, install Node.js. As simple as it could be, right? When I go and click on this install Node.js, the first website that comes up, right? Nodejs.org/en/download. As you can see here, there are different types of options that you have. As you can see on the screen right now, right? Depending on if you have a Windows, you have the option for the Windows. If you have a Mac, you can go and make use of, for example, I'm right now executing everything on my Mac machine, so I can make use of that. If you have something else, right, for example, Linux-based system, you can go and make use of it. So installing Node.js is super simple. In today's modern world, when you guys are playing day in and day out by installing different types of applications, softwares, installing Node.js is no big pain, right? So I'm just expecting you people that you go to this website, nodejs.org/en/download, and then depending on which operating system that you are using, right, whether you are using Windows, you are having Mac OS, whether you have a Linux, choose appropriate and then accordingly go and do. So for example, for the Windows you have the .msi file, right? Depending on what operating system you have, 32-bit or 64-bit, you can choose one and get things done. So I'll not try to take too much time on this because this is very super easy. A simple Google search will help you do that. So I'll try to spend more time, which is more conceptual, right? So I'm expecting that you people will be able, if you don't have Node.js, pause this video for some time, install it, and then put that into the comments that yes, I have installed Node.js and I'm good to go. Right? The operating system that I'm playing with is Mac. I'm trying to show you that how I'm going to install Node.js in my operating system and how I get started with it. You can follow the similar steps if you're a Windows user or a Linux user, right? So let's get started on this. So what I go and do, because by default it is showing Windows, so I go and click on this Mac OS installer. As soon as I go and do it, if you can see here, this package got installed. I double click on this. Right, I have installer. So I click on this continue. Then I again click on the continue. I have to agree, right? I don't want to change any kind of installation directly. I want to keep the things as default. So I go and click on install. I have to go and make use of my password. Let me go and pass my password. So it will take few minutes, run some background jobs to make sure that Node.js is all up and running and is available in your system. So as you can see here, right? So if you try to see here, let's try to understand this in a better way. When I install this package, I got two things installed, people. One is Node.js, right? One is Node.js, and with that I have also got one thing installed for free. What is that? This is npm. I got installed something called as a npm. Now what npm is, why do we use it, why it is relevant here, we are all going to talk in details in some time now. But for now, you understand that when you go and install Node.js, two things happens. You get Node.js installed and at the same time npm as well. Now once I have installed npm, right, I can do and go close. But how do I know that Node.js is installed, up and working in its all correct state? So for that I go and open my terminal. Similar thing, let's say for example, if you guys are working on the Windows, you can do the similar thing with your command prompt. Since I'm using Mac or a Linux, I might be using the terminal, right? So here I go and type node -- version. When I go and do this, I have got this, the node version 18. As you can see that v18.17.1. So 18 version of the node has been installed on my machine. So my node is available. This is a kind of a proof that node is properly installed on my system. The next thing that I would like you people to know here is that when I go and type node, what it opens up is a kind of REPL environment, right? What it does is, as I told you, Node.js is a JavaScript runtime. So this provides you a way to run a JavaScript code in the console itself, in your terminal itself, in your command prompt itself. Say for example, if I go and say that console.log and I say that hello students, and I type enter, it will print hello students. So you can think of that any JavaScript that you have today, which you were initially writing in the browser, you can do it here. Let's try to do another example. For example, I go and say that const a equals to 5, const b equals to 6, and let's say that then I have to go and print console.log a plus b. So as you can see here, when you move from one statement to the another, this Node.js REPL environment makes sure that it remembers everything. So once you defined a equals to 5, it was remembered. When you defined b equals to 6, it was remembered. And then when you type console.log a plus b, it is able to compute that computation and put that into the results. So this is as simple as that. So we have seen right now that how Node.js could be installed in your operating system, in your laptop, the kind of environment that you have, depending whether Windows or Mac. And in order to check, we have to type node -- version. It will tell you which version of the node is installed. And when you then type node, it opens up a REPL environment, REPL environment, where all the JavaScript that you want to execute could be executed. So it's a quick way of testing the code that you'd like to execute. So now let's try to move on to the next section. So we have seen that node is installed. We saw that how node could be verified. We saw the REPL environment of the node. Now let's try to address the next elephant in the room. We saw that when we installed Node.js, with that came something called as npm. With that something called as npm. So as I always try to stress upon, whenever you are learning something, always try to do in two ways: what and why. So first of all, what is npm? So NPM stands for, NPM stands for Node Package Manager. Node Package Manager. So this is what? What is Node? NPM. NPM stands for the Node Package Manager. But why do I need it? Why is, what is the need of this? What is the Node Package Manager and why do I need it? Let's try to understand with the help of a common example. Say for example, in your house, right? In your house, let's say that you have to do a very simple chore, right? You have to make something called as tea. Now for making tea, you need few ingredients, right? For example, you need something called as a milk, you need something called as a sugar, you need something called as a tea powder. So when you have to make tea in the house, what do you normally try to do? All these things that you have, this milk, sugar, tea and powder, you go and purchase from the market, right? Either you do through the online shopping, through the grocery marts, or you go there in the shop and go and get it done, right? And when you have all these three together, you can make tea very quick in say like 2 minutes. But let's say that you decide that, okay, my tea, for everything which is needed to make the tea, I'll do it myself. I'll have my own milk. I'll go and bring lactate cow and make sure that, I'm getting the milk. I'll go and, first of all, do the crop of sugar cane and then convert that into the sugar. I'll try to, have my own farm of tea plants and then I'll have the tea powder. If I want to do everything from the scratch for the ultimate project, the ultimate thing that I'm trying to do, I might have to invest a lot of time, a lot of money and a lot of energy to do that, right? So making a single tea which you can make today in 2 minutes might take you few years, right? If I'm not wrong. So what is the moral of the story? The moral of the story is that when you try to build something, you don't need to start everything from the scratch. You need to learn from someone else. Some people have already built some raw product. You make use of it to become more finished product. Same logic if I go and apply in the world of programming also. When you working for a company, when you start working for a company, right? And you have to create a project. You have to go and create a project. Now, when you have to create a project, it's always wise that you don't start from the scratch. If you already have some code base, if you already have something to refer to, why not use that so that your development time, the lines of code that you have to write could be reduced. Say for example, you have some CSV file and in there is some data. And for this data, you have to apply some logic. This logic is important for you. Now for this, let's say that you're writing some code, right? So what could be the 2 steps of writing the code? The first step should be that, one, read from the CSV, read from CSV. And the number 2 should be that apply the logic, apply your logic. Now if you see the first part of the statement, reading from the CSV is a very common problem. This is a very common problem. This problem definitely some other people would have already solved. So when you're trying to work on this project, why not make use of the code which other people have written to read the CSV so that you don't have to put your brain, time and lines of code to achieve that. So we do this, you try to take this, take the code from someone else to read the data from the CSV and you only apply your brain, which is your personal logic, which is customized to your business needs. So many of times when you start working on the projects, you would not like to start from the scratch. You need that you get all those things which is already available in the market itself, right? And that's where the NPM or the Node Package Manager helps. So just like, for example, if you have to go and take the items, if I take the analogy, if you have to buy the items, you go to something called as a supermarket, right? Or you go something called as an Amazon, right? And from there you get all these items delivered to your doorsteps, right? From the Amazon in the online mode, from here it comes in, right? Similarly, in the world of Node.js programming, the world of Node.js, the world of Node.js, if you are building an application, right? If you have an application and your application has the dependency, all these dependencies are present in something called as a node npm registry. It's a remote online place. So you can think of the node npm remote repository at a place more of like an Amazon where you find everything that you need to buy. It's more of like a supermarket for node.js code. So every time any developer, they build something new and they would like that, the world should use it or they should be aware of it. Let's say there's a developer called as X. He built something for the CSV reading, right? There's some another developer which helps in the image recognition. So all these people keep on pushing their code here. So basically this node npm registry is online portal where you will have millions of the code bases which the developers from all the part of the world have kept it so that people can come and use it. Okay, so for example, your app need anything. Let's say that the app needs something, for example, Express. Let's say that app is needs something called as an Express. We'll talk about the Express later on, but let's assume that Express is something which my app needs. So this app has to actually go to the node.js npm registry, right? It has to go there and then from here it will get it back. Who helps a node.js application to get this dependency from the central repository? What is that entity which helps app to get the node.js libraries, the code base, the reusable portion of the things, the libraries from the npm registry? That guy is called as npm. Just like, for example, Amazon app is a way through which you can order, so that when you order egg or you order grocery, it comes to your house, right? So you make use of Amazon app to order and then Amazon helps you get it delivered. Similarly, an application makes use of npm, right? Node package manager, to fetch the dependencies from the node npm registry. Npm registry is a remote server, right? It fetches that and gets you data in your application. So this is the prime function of node package manager, right? So if I now go and simplify this whole stuff, now let's say that this is your computer, right? And then this npm registry will be running somewhere remote, npm registry. It might be running on some kind of remote servers. So whenever, because your system has something called as npm, your system now has npm. So whenever you go and say that, dude, I need Express, through npm it will try to make a connection to this guy, npm registry. It will try to search here and then fetch the data back to your laptop and then do in a local storage. And obviously, since these are the two remote machines, for this you need to have effective, you have to have a network. You need to have a network connection. If you have to make use of npm to install dependencies for you, you have to have a working internet connection, because then only your laptop will be able to go and connect to the remote npm registry. So the major uses of npm node package manager is to ensure that whatever the external dependencies that you depend on, you go and fetch that. But this is just one of the most important factors which npm does. npm also helps in multiple ways. For example, few of the ways of the npm could be that it helps you for the dependency management we only talk about. That's one. The number two is that it also helps you to create node project, create node.js project. It helps in the project management. And I told you, many of times in the npm registry, right, there are many people who are actually contributing back, right? Here I am talking about using that But there will be some people who will be contributing that to the NPM registry so that other people can use their code. That also could be done with the help of NPM itself in the push code to NPM. Now let's try to understand with the help of an example that how NPM helps to create a node project, and also see how the NPM registry looks like. Let's try to go back to my laptop. So now again, if I go back to my browser, right, let me go and type, let me go and type NPM registry. If I go and hit open, the first link that comes up, this is the place which contains almost all the important packages, all the important codes, all the important libraries which you can think. You can build your application on the top of that. All the basic problems has already been solved, people, right? So you don't have to write the code with scratch every time. When you work for a company, time is also very critical. So you have to make sure that all the dependencies that you depend upon, why don't you go and get it from the NPM registry, and this is how the NPM registry looks like. So if you look around, there huge list of the, for example, let's say that if I'm trying to search for Express, if I go and search this, click on the search, I have this Express. So this I'm doing right now manually on the browser, the same thing the NPM does for my application through the code. So we'll try to understand with the help of an example. So let's try to deep dive. So now the first thing that I would like to do now is build a Node.js project. So let me go to my terminal. Let me out of it. Now let me try to create a Node.js product here. So let me go to my CD work. CD mkdir, and I'm going to call it as node demo. And then I go inside the node demo. Now what I did just right now is that I created this folder. Let me mark this. So I created this folder, right? I have created this folder. So I created this. This mkdir is basically a Linux based command which helps you to create a folder. And then I have inside this, I'm inside this folder, which is the node demo. So whenever you have to go and create a project, you always have to keep two things in mind, that decide on folder location, create that folder, and then you have to go inside it. Once you have done this, the next step that you can do is you make use of now npm. This is the first uses of npm that we are doing. We're going to say npm init. So when you go and say that npm init, what it will do is it will try to convert the folder where you are in into a node.js project. But before it does it, it will ask you a few questions, that what is the name of the project. If I don't provide anything, whatever is the name of the folder, that name itself will become the name of the node.js project. So here, if I don't do anything, if I click enter, it will just take node demo. The next part is the version. We know that all the software is all about the version. We keep on improving it. So let's keep it default. The first version of the project, let's keep it as 1.0.0 itself. So I don't do anything. Description, I can go and write this is a demo node.js project for my students, right? If I go and click enter, then it's saying entry point. We'll just try to ignore it for now and we'll talk about it later on. In simple terms, if I have to say that the project might have multiple files, what is that starting point? What will be the gate? Just like every house has a main gate through which you enter, similarly every project will have some file which acts like a gate, like an entrance. So what is that entrance point? What is that entry point? So that will be the name is index.js. I'll not make any changes. I'll just keep enter. Test command, when you write something, you need to run some test, integration test, unit test. Since we are not doing it as of now, we're not going to put anything around here and I'll just ignore this. Now Git repository. Anytime you write a code, you definitely would like to have some kind of remote backup. You would like to have the versioning. You would like to go and share it with the world. So if that is the case, you have to go and provide that what is the Git repository link. But as of now, since I don't have, I just keep it blank. Any keywords that I would like this project to be associated with, right? Say for example, on a YouTube video, you know that every YouTube video will have some tags. So that when you search with that tag on a YouTube, you are able to quickly find that YouTube video. Similarly, when I'm creating a project, I would definitely want that someone in the world might get benefited from it. So for every project that I build, I go and add certain keywords. So for example, let's say that this keyword will be the node. So anyone searching for the node should be able to get this project. Author, so let me go and put my vishwa.mohan@pw.live. License, it's open source, not applicable, so I don't keep it. And then it goes and tell me that, dude, this is how it looks like. Does it look okay to you? I think it looks okay to me, so I'll go and say yes. So as soon as it is done, my node.js project is ready. As soon as it's done, my node.js project is ready. As if you can go and quickly remind what all things that we did. If I quickly remind, what all things that I did was that I first of all go and create this folder. Then I went to this inside this folder and I did this command called as npm init. So keep this command in the mind, guys. Npm init is the command which helps you go and get started. Npm init. This helps you create a node.js project. Like it helps you create a node.js project. And once that was done, I had certain things prompted. Right? I had certain things prompted that what is the name, right? What is the version, for example, what is the project name? I didn't give anything, then the version, then the description, then the entry point, and all those things, and my project is ready. Now, since my project is ready, I want to use it in a proper way. So, one of the most widely used integrated development environment, IDE, for the node.js project is VS Code. Now, this session is not about the VS Code, so I'm not going to talk more on that. But I'll expect that, you people should do something. So what I'm expecting is that in order to make the best use of this, to see this project, I'm going to make use of something called as VS Code. You can use other IDs also, that's not an issue, but this is something most commonly used and very friendly, easy to use. So I'm going to make use of VS Code. So this thing you have to first, get it installed. And once that is done, the next step that I'll do is that the step number 2, it will be that open the code. And then we'll take all these things going ahead. Since this is not a video around the VS Code itself, so I'll try to keep it concise, but I'll show you people that how do we go and install it very quickly and then get started with this project itself. So let me go and close this. And let me go to my browser. And let me put it here. Install VS Code. The first link itself that I get is the one which talks about that how VS Code could be installed. So be it Windows, be it Mac, be it Linux, whichever operating system that you have, I believe you have an option to go and install it. This is very super simple. As we have installed node.js, a similar step we can follow. Few clicks and the VS Code editor or IDE will be installed on your local machine. Am I clear, everyone? Now I want you people to make this session as fully hands-on. Right? So don't take any shortcuts, guys. Pause the video, install VS Code editor if it is not there, and then you continue the video from there itself. So I'm hoping all of us have the VS Code editor already running in our system. Since we have, let me go and open my VS Code. Okay. And now what I do is that I'll go and open this folder which I created. So this folder was inside the work node demo. If I go and open this, this is how the folder looks like. Now, if you remember, when I created this project called as node demo, it was an empty folder. But when we did npm init and this whole project was getting provisioned, getting created, a new file automatically got generated, and that file that you see on the screen, people, is package.json file. So every time you create a node.js project, npm, what it does, it will go and create a package.json file for your whole project. So let's try to understand what it is. So if you look around here, this is your project root directory or the parent directory, right? And inside this, there is a file which got created called as a package.json. Package.json, normally people, you'll find that it will have the information about the project. So if you remember, when I was creating the project using npm init, I gave the information about the name. I gave the information about the version. I said the description, this is a demo node.js project for my students. I said that what will be the starting point. For the test, I didn't do anything. So it is saying no test specified. Keywords I added was the node, author is me, and the license, no, just standard word that has been put up. So this package.json is nothing but it just specifies your project metadata, what all the things that your project is made up of, right? I also said that, when I make use of npm, it's one of the biggest use is the dependency. One of the biggest use of the npm is the dependency management, right? How do we do the dependency management? So to do that, and how does then this package.json structure will change? Just look at this, sir, how this package.json looks right now, and we'll just take a quick look. Once we add a dependency using npm, how the structure will change. So we'll go and close this. What I'm going to do now is, let me open a terminal. I can open a terminal inside this itself. And let me go and type npm. So now since I have to go and have a dependency, I go and make use of npm. And I'm saying npm install, and let me go and make use of express. What express is, don't worry now, I'll have a separate session where we talk mainly around the express. But for now, just think that express is a dependency, is a external dependency which my project depends on. So I go and say that npm installed express. If I go and click enter, as soon as I do it, you'll see that few more changes has happened in this entire project. So the first point that I want you guys to be focused upon is to have any dependency, you make use of this keyword called as npm install. This is the keyword which is always fixed, and this is basically the dependency that you want to install. Since I have an active internet connection right now, it is saying that when I did this, 58 packages got created. So it brought it express. And if you see on the left hand side, initially I only had package.json, but now I have two additional files that have got created. I have got created this package lock.json, and I have also something called as node.module. This is basically a directory got created. This is not a file, this is a directory that got created. We'll try to look each of them in detail and understand what it is. First of all, let's try to understand that what are the changes that has happened in the package.json. So if I go and open the package.json now, let me go and minimize this. In the package.json itself, a new section got added. In the package.json itself, this is the new section of dependency which have got added. Now I have another field called as dependencies where express which I installed got added, people. So now package.json is not only talking about what this project is all about, but is also telling me that what are the dependencies this project depends on, and this is depending right now on express. Which version? 4.18.2. So this is one change that has happened. So every time you keep on adding the dependencies, it will keep on getting added inside this dependencies key. That's one. The second change that you see here is that node modules, right? Let's try to see what is the content of this. Let's try to see what is the content of this node modules. So if I go and expand this, I see that inside this I have something called as express here. When I go and open this node_demo, I see that inside I have something called as an express here. But I was only looking for this. What about these guys? Why these people have been added? Can you guys help me understand this answer? Can you pause this video and tell me that I only told npm that you go and bring express. But what I see is that apart from the express, 50 other dependencies have also come in. Why is that happening? This is happening because when I talk about npm, you can think of npm like your mom. Not as good as mom, but somehow near to that. Why I'm saying mom? Because moms are smart. Let's say that you go and tell your mom that, mom, today my friends are coming for dinner. Friends for dinner. You only have to say that the first step, that my friends are coming for the dinner. But when your friends are coming for the dinner, it has lots of dependencies. It will require that, food arrangements. It will require for the music. It will require for in the food itself. There could be multiple items, right, that the mom has to prepare. So you don't have to tell each and every instruction. You just have to tell mom, and your mom is smart enough. She knows you so well that depending on who that friend is coming, she will make sure that the best of the food is available. When you go and say that npm please bring me express for it, express in itself is not independent. Express itself depends on multiple things. Just like the dinner of your friends depends on multiple things, like there's the right food, there's a place for the people to sit, there's a music to play, right? Multiple stuff. Similarly, if I have to make use of Express, Express is also a Node.js project. Express might also be dependent on multiple things. So when I go and said npm bring Express, npm is smart enough that it not only brings Express, but also the dependencies. I go and call those as indirect dependencies. So since I brought Express, all these things, Express depends on this, Express depends on this, Express depends on this. So all these dependencies are also brought without you telling them explicitly. So every time you go and tell npm that npm dude, you get me the dependency, what it does, it goes to the npm remote, and from the remote it brings and stored inside a folder called as node_modules. So it brings all the dependencies and downloads it here inside this node_modules, inside the node_modules, right? So if I go and bring this up, everything comes inside here. So once we have understood this, let's try to come down. Let me go and minimize this. And if come here, we have another file called as package.json. Package.json. So here, if I try to look around, if you see there, in my package.json, I only had one dependency called as an express. But I know that express internally depends on multiple dependencies. So basically this package lock.json not only talks about the direct dependencies but also the indirect dependencies. So it contains information about all those indirect dependencies which npm has brought to the table. So this is how Node.js projects are built using npm in it. And this is how the structure node_modules, package.json, package-lock.json are created, and these are the purpose for it. I hope everyone is crystal clear till this point. Now, since we are clear, we'll try to move to the next steps of this programming. So now let's understand other properties of Node.js. So when we were talking about Node.js, we said that, when we are defining the Node.js, when we have been defining Node.js, we said that Node.js is asynchronous, event-driven, runtime environment. We already talked about, few of these terms, that what is runtime environment previously, right? We already talked about this. Let's try to understand this concept called as asynchronous. What does it mean? Opposite of asynchronous typically is called as a synchronous. We all have been habitual of doing the synchronous task. So let's try to understand with this, with the real world example, that what synchronous means to us, what is the meaning of asynchronous, and how in JavaScript actually, basically, JavaScript Node.js typically how that's gonna execute it, right? So let's first of all understand the meaning of both synchronous as well as asynchronous. So let's start with something called as synchronous. Synchronous means that, in very simple terms, if I have a problem statement, right? If I have a problem statement, and this problem, in order to solve, there are multiple steps. There is step 1, step 2, and step 3. And only if I am done with the step 1, I can go to the step 2. And only when I am done with step 2, I am done with the step 3. It means that, no, I am going one after the another. This kind of execution is called as a synchronous execution. To solve a problem, if there are multiple steps, and only when I have solved the step 1, I can go to the step 2, and only if I am done with the step 2, if I go to the step 3, this is called as a synchronous execution. Unless until I am not done with step 1, I cannot go to the step 2. I will be here blocked. Unless until I am not done with step 2, I cannot go to the step 3. I am blocked at step 2. Just like, for example, unless until you have passed your 10th examination, you cannot move to the 11th. Unless until you have done your 12th, you cannot go for your engineering. So these kind of steps, only when you do 10th, then you do 12th, then you do engineering. That's typically example of synchronous, or this is also termed as blocking. This is also called as blocking. Why blocking? Because at every step, only if you are done, you are allowed to move to the next step. Let me give you a real world example, a little funny one, so that you never forget in your life what is the synchronous programming. So let's say that there's a guy named Rahul. Let's say that there's a guy called as Rahul. Right? And let's say that Rahul, girlfriend's birthday is there. Okay? Rahul's girlfriend's birthday is today and Rahul wants to surprise his girlfriend. So that's why he goes to a bakery shop to find the best cake in the market. But as soon as he reaches here, the bakery shop guy, as soon as the Rahul reaches the bakery shop, this guy tells him that, the cake will take at least 30 minutes to be, to be baked and prepared. Now, since Rahul loves her girlfriend so much, he doesn't want to take risk that if I go out of this shop, maybe this bakery owner would sell this cake to someone else and he might not be able to bring the cake for her birthday. So he does not do anything. He's just waiting. No, he's not doing anything. He's just there waiting. Right? Totally blocked for the cake to be ready. He's not doing anything, and only when the cake is ready, then he takes the cake and then comes back. Again, he takes the cake and comes back after 30 minutes. So this scenario where Rahul went to the bakery shop owner said that, dude, it will take 30 minutes for the cake to be prepared. He waits there till the cake is done. He's not doing anything else, and after 30 minutes he takes the cake and come back home to celebrate the birthday. This whole thing which Rahul did is an example of synchronous task or a blocking task. I hope all of us are clear what is the meaning of synchronous. So what is asynchronous? If I take this same story, right? If I take the same story, instead of what Rahul did in this case, let's say that I have another guy called as Vihan, a modern name, and he is a modern practical guy. Let's suppose that his girlfriend's birthday is also today, right? So what he did? He also went to the bakery shop. He is waiting there at the bakery shop. Tells the guy that, can you get me the best cake of the town? But the bakery shop owner says that, dude, it will take you 60 minutes. Vihan, being practical, he feels that if I just stay idle here for 60 minutes, it will just waste my time. Why not I make the best use of this time itself? So Vihan says the bakery owner, dude, give me a call when the cake is ready. I'll be back to pick it up. And in the 60 minutes, the Vihan feels that, why not let's go and meet my another girlfriend. Right? So Vihan goes and meet his another girlfriend. A practical guy, a model lover of 2023. On a lighter note, he goes and meets for the another 60 minutes. While the cake is getting cooked, while the cake is getting baked, this guy Vihan is not blocked. He is not not doing anything. He went with someone else, and as soon as it is done, he got a call back. So he returns back after 60 minutes, takes the cake and come back. Takes the cake and come back here again. At the step number 2, when the cake was getting baked, Vihan is not stopping from doing anything. He just proceeds away. Right? He does something else. And when the cake is done, he is being called upon back that, okay, cake is ready. He takes the cake and goes back. This type of functioning is called as a synchronous task. So if I put that in the form of an example of a problem statement, right? So if I have a problem statement, for example, problem, if that involves the steps, step 1, step 2, step 3, And everything is kind of sequential error. Only once step 1 is done, step 2 happens, step 3 happens. This is an example of synchronous processing. On the other hand, if you have a problem, and in that case, let's say that step 1 and step 2 can happen in parallel, and then step 3 happens, right? So multiple steps are happening in parallel. This kind of processing will be called as asynchronous processing. Asynchronous processing is also sometimes called as non-blocking. Asynchronous processing is also sometimes called as non-blocking, whereas synchronous processing will be termed as blocking. Now let's try to understand the advantage of it. Let's say that step 1 takes 10 seconds. Step 2 takes 15 seconds. And step 3 takes 5 seconds. In the case of the synchronous processing, what will happen? I will have to add all 3. So total time that will take will be 10 plus 15 plus 5. That will be equals to 30 seconds. Right? On the other hand, if it is asynchronous programming, if the step 1 takes 10 seconds, step 2 takes 15 seconds, and this takes 5 seconds. Since this was step 1 and step 2 is happening in parallel, so by the time step 1 and step 2 is completed, it will take how much? Only 15 seconds, which will be followed by the step 3, which is 5, which equals to 20 seconds. So the things if done in the synchronous way will take 30 seconds. The thing which happens in the asynchronous way, it takes only the 20 seconds itself. So I believe now all of us would be clear by now that what is synchronous task and what is asynchronous task. Am I clear, everyone? Does it make sense? Put that into the comment in this YouTube video. So now let's try to understand both how the synchronous and asynchronous processing happens in the case of JavaScript Node.js. Let's try to understand that with the help of an example. So let me move back to my laptop. So we'll start with understanding what the synchronous programming looks like. I think it is on the screen. Let me create a file called as let me go and create a file called as sync.js. So we'll get this file, we'll take example of take an example of synchronous execution. Okay, I hope it is all visible. Let me increase the font a little. So now let me go and write a function. I'm writing a simple JavaScript. Let me go and call it as a greet. And inside this greet function, I go and return another function. And I go and call it that console.log, and I say that welcome students. So this is one function that I have written. And then what I do is that const, and I go and say that result equals to greet, and then I go and call it as result. So this is a function. If I go and run this, so if go to the terminal, if I have to go and run this typically, right? So I can simply go and say that node. So if I go and execute this, this prints welcome students, right? What it does, it prints the welcome students. Let's try to understand this, how this whole execution of the synchronous execution of the code has happened. So let's go back to our screen and try to understand this, that how did this happen. So what happens is that in JavaScript, whenever you start executing things will always execute from the top to bottom, right? So the code will be executed from the top to bottom, one after the another, right? So whenever you load any file, sync.js, what happens? There is a concept called as a call stack gets created. We have something called as a call stack. The call stack gets created. Call stack is basically a stack data structure. I think most of you would be already aware of. Call stack is a kind of a stack data structure which follows the order of first in, last out. Very similar to if I give you a real world example when you go to the restaurant, right? And in the restaurant, basically for a buffet, if you go, right, you will find that plates will be kept in order. The person at the restaurant will arrange the plates, and the plate which was kept last on the top is the one which gets picked the first when a customer comes in, right? And the plate which was kept first at the bottom is picked the last. So that whole structure in which the plates are kept in the restaurant is an example of the stack data structure. First in, last out order. So every execution that happens in a JavaScript, for that to be executed, anything which happens in the synchronous order, for that to be executed, it goes inside a data structure which is of the nature of the stack, and that is called as the call stack data structure, right? So as soon as I go and execute, I say that node sync.js. As soon as I go and type this word, the very first thing that happens is that global execution context. Global execution context. Let me write it out. It is called as global execution context. This global execution context gets created, right? And this global execution context first of all gets pushed inside, right? You go and push this inside the stack. So the global execution context comes inside the stack. Once that has happened, it will move line by line. So first of all, I come at this line, right? At this point of time, only the function body has been written. It is not executed. So what will happen? Some memory will be allocated for this function, but nothing happens inside the call stack, right? So from the line number 5 till line number 9, when the line of execution is happening, some memory will be located for the function greet, but nothing will happen inside the call stack. Now at this point, when it comes to the line number 11, this greet function is called. So as soon as you execute a function, a local execution context for this greet function is created, right? And this greet function, local execution context of the greet will come inside this call stack. Correct? And now what happened? The execution of greet will happen. So this gets pushed again. The local execution context of the greet function happens, right? Then I come here. Inside this, a function is created and it is getting returned. So when the greet is executed further, right? When the greet execution happens completely, it is again pushed out. It is popped out. So what happens? Every time a function is executed, it is put inside the call stack, its execution is over, then it is popped out. So as soon as it popped out, I'll go and delete this. As soon as it is popped out, I'm gonna delete this, right? I'll gonna delete this. So that got popped out. Let me go and delete this part. So now my, the call stack only have a global execution context. And then I come at the line number 13 itself. So this function, right, the result is nothing but pointing to this function which got returned, right? This function is again executed. So again, this function which got created, this function again is popped in, right? Popped, pushed in. So whenever you push anything inside a stack, you go and call it as a push operation. When you take that out, you go and call it as a pop operation. The function which got associated to the result is again pushed inside this call stack. This, when it is executed, right? When it is executed, it goes and prints welcome students. Welcome student gets printed in the console, and then finally it is again popped. When it is popped out, this function is kind of deleted, right? This whole thing will also get deleted. And then finally nothing is left. So finally this GEC will also be, the global execution context will also get popped out. So at the end of a day, when everything is done, the call stack becomes empty. This becomes empty, right? Which means that everything is done. Everything is done and completed. So in order to revise, whenever there is a synchronous execution, everything has to go inside the call stack when you're trying to execute it. It all starts with the global execution context which gets pushed inside the call stack. Then line by line the execution happens from the top to the bottom. Whenever a function is about to be executed, it goes inside a local execution context for that function is created and it goes inside the call stack. And when the execution happens, it again gets popped out, and that's how the entire execution of a program in a synchronous way happens inside the case of the call stack. Since now we have understood synchronous, let's try to take another example of asynchronous code and understand that how that happens. So now what we'll try to do is that we'll try to understand that how internally Node.js does the async execution for the code which is getting executed in the asynchronous way. So first of all, let me try to write the code and then we'll see that how the execution will happen internally, right? So for example, let me, I already have created this file called async.js. Let me write some code of, console.log. Just put it a little up, console.log. And I say here, hello students. And then post that, we're going to call a callback function. Let me go and define as a function callback. And this function has another console.log and I'm going to call it that hello again from the callback. Perfect. And once this is done, the next thing that we do is that we're going to make call of the asynchronous function that we get from the web API. So I'm going to call a function called it set timeout. And in this, I go and pass this callback function that we have defined. And I say that this should get executed after 2 seconds, right? 2000 milliseconds. I go and call this. And then finally, I again do a print call console.log and I say that hello from the final line. I go and call it as hello from the final line. Now, if I go and save this file and run this, let me go and run the node. If I go and save this file and run this here, node async.js. If you see first the hello student is getting printed, then hello from the final line and then hello again from the callback. Let's try to see in detail from the screen itself that what has happened. So now if you see here, we know that already in the case of JavaScript, whenever the execution happens, the execution always happens line by line, right? So the execution will start from top to the bottom, right? The execution will always start from top to the bottom in this way. So first of all, what will happen as soon as the execution starts, we already know that in the very beginning, something called as a call stack gets created. What happens? The call stack gets created. We're going to call it as a call. And in the very beginning itself, what happens when the call stack gets created? The global execution context, we already talked about that. The global execution context is pushed inside this call stack. Very nice. Then this first line execution will happen. So what will happen? This console.log will be pushed. Console.log thing will get pushed and this execution happens. When this execution happens, what happens here is that you see here this hello student, as you can see here, this hello students get printed, correct? Now once this execution has happened, this should be again popped out. This should be popped out. So since it is popped out, so it will get removed. So what I'm going to do now is that I'm going to delete this. The next step happens is that I come here. Now since this is just a callback function definition, so nothing happens here. Just some memory will get allocated to this function. So the memory will get allocated from the line number 3 to 5. Next, I come to the line number 7. Here is the interesting part. This set timeout is basically a synchronous function which comes as a part of web API. So as soon as you go and hit something called set timeout, this callback gets registered to a new entity. A new player comes into the action which is called as a web API. A new player comes into the action that is called as a web API. And with this web API, this callback function will get registered. So with this web API, this callback function gets registered, right? This callback functions get registered here. and the timer starts, and because of this the timer starts, with this timer. At the same time, a new entity comes into the action which is called as event loop. Event loop. This guy will keep on having an eye over the web API for this timer thing to see if the timer is up or not, if the 2 second which was the timeout for this callback function, it is done or not. As soon as that will be done, there is another entity which comes again here in the action, that is called as callback queue. Callback queue. Another action that comes up is called as a callback queue. This is a callback queue. So the event loop will keep on seeing that the function which has got registered to the web API, the timeout which is the timer which is associated with it, as soon as the 2 second will be elapsed, this callback will be taken out. This callback that you see here will be brought inside this callback queue. Callback queue is basically a first in first out data structure, similar like a queue, right? And as soon as all the callbacks which are registered to the web API, when their timeout is done, when their execution is done, typically they are brought to the callback. Now, this event loop that you see, this has a very important role to play. He is a manager of managing the callback. So at one, it will try to see if the timeout is done, so that it will try to move the callback function which was registered with web API to the callback queue. And then also it will keep a look at the call stack. If the event loop finds that the call stack is now empty, only then it can take out that function which is inside the callback queue and put that inside the call stack for the execution, right? So now what happens, as soon as we do this set timeout, what has happened? Callback got registered to the web API, timer got started, event loop have started observing the web API, so that when the timer will be done, the callback will be moved to the callback queue. And now I move to the next line, which is the line number 9. So the line number 9, again the console.log. So console.log again gets pushed in, right? And this gets executed. So when this gets executed, this gets printed at the second line, as you can see that hello from the final line. And once the execution of that has happened, it again is popped out. When it is popped out, again I'll go and delete this. Now since nothing is left, so this global execution context will also be popped out, right? So again I go and delete this thing, right? And now my call stack is empty. Now this guy event loop sees that this is empty right now. So what it will do, it will take this and put it inside this. So now this will have the callback function inside the call stack. And then this function gets executed. This line will get printed, as you can see here in the line number 3. So this is how typically internally the callback function, the synchronous code, is executed using the complex interaction of call stack, event loop, web APIs, and the callback queue. Now, in order to understand these things very intuitively and why it is needed, let's try to understand. Let me go back to the slide and help you understand with a more intuitive example, right? So let's go there. So if you talk about why do we have a need of the asynchronous execution of JavaScript, why do we need it? We need to do this because JavaScript is single-threaded. And since JavaScript is single-threaded, if it does not do asynchronous processing, everything will be super slow. Everything will be blocked. Let's try to understand this with the help of an intuitive example. So think of, since JavaScript is a single-threaded programming language, think of replace JavaScript with a restaurant owner, with a restaurant. What is a single thread? JavaScript thread. When I go and talk about thread, means something which does the work, right? Similarly, let's say that just how miser a JavaScript is. Let's say that I have a restaurant which only have a single worker, right? So let's say that this is a restaurant, this is how it looks like. Let's say that there are multiple tables here. Table 1, table 2, table 3, table 4, table 5, table 6. Right? And let's say there is only a single waiter or a worker in this. Now if it starts working in a blocking way, what that means that let's say that it goes to the first table, takes the order, goes to the kitchen, take back the order back here and stands here till this table is done. Unless until the first table order is completed, the waiter is just sitting on the first table itself. Let's say that the average time that it takes is 30 minutes. It means that only when the first table is done, the waiter will go to the second table. Again here it will take 30 minutes. So by the time the waiter goes to the last table, this person who is sitting here will have to wait at least for how much? 3 hours. Which is too much of time. Do you think you will have enough patience to go to a hotel and wait for 3 hours for the food? No one will wait, right? This concept of working will not work. Either I'll have to have more waiters so that multiple waiters can cater to the multiple tables, or I'll have to find some other strategy. So let's say that if this guy learns from the asynchronous processing of JavaScript and Node.js, what could they do? You can just pause the video and just think of that what this restaurant owner with just a single worker, a single waiter should do, that they are still able to manage multiple customers without impacting their service quality. What they can do, guys? Right? So let's try to understand what they can do. So let's say that this same arrangement right now. So I have 6 tables. 6 tables, right? And then I have something called as a, I have a kitchen. In the kitchen, there's a coordinator. And then there's a cook who makes the food. And then I have this guy called as a waiter. Now I know that the waiter or the worker does not cook food himself. Right? So he does not have to wait on the table for the food to repeat. So what he can do? He can jump to this table, take the order and go and give this to this coordinator. Coordinator will put this to the cook. And then as soon as it is done, it comes back, goes to the another table. Similarly, gives the order to the coordinator, put that another to the cook. And it goes to the third table like this. As and when the food is ready, as and when the cook is able to prepare the food, it gives it back to the coordinator. It gives it back to the coordinator, right? Or, instead of giving to the coordinator, what it can do is, when the food is ready, what could happen is, this cook can, put that at some, counter. On some counter, the food items could be kept, right? So as soon as the food counter is available, right, this guy can look into the counter and call the waiter. So now what happens? Single waiter is still able to do the things. He just goes to the table, takes the order, gives the order to the kitchen, and then goes to the next table. Again, do the same thing. And as and when the food is ready, the coordinator will make a call to the worker that, hey dude, the food is ready and now you can take it and go and serve to the customers. So if you try to do the analogy of the previous stuff, if I go and talk about this waiter, the worker himself is actually doing the work, actual execution. So you can think of it more of like a call stack. Right? On the other hand, this cook, where actual operation happens, the waiting happens, you can think of it more of like a web API. Right? After the cook is prepared, it is waiting on the counter. You can think of counter as more of like a what? More of like a callback queue. And this coordinator who is looking around when the food is ready to be delivered to the waiter so that he can go and serve the customer, you can think of that like a event loop. So that's how typically the whole asynchronous processing of JavaScript happen in the Node.js. And ladies and gentlemen, this is one of the mostly asked questions. So if you have not understood this concept, please pause this video, go back, watch this again. because this is one of the most toughest, the most complicated and most asked question in the interview. So take some time, hold on, recollect your thoughts, go back to the video, watch it again, and before you proceed further, make sure that everything that we have discussed so far is crystal clear to you.